All right, this is Statistics Day 4, going over the answers to Homework 2, the worksheet, or you did it on your own paper, that's fine as well. All right, so for the first one, for the mean and standard deviation, I just simply put that into the calculator and let the calculator do all the work. Got my list, got all the numbers in the list. Do my stat calc, one variable statistics, and up here is the average of 79 and the standard deviation of 12. Remember the mu right here is the average, the sigma is the standard deviation. So to draw the normal curve, I like to start at the bottom, find my center, which is the average of 79, and try to get my curve. Oh, that's a little better than I did last time. Remember, you are going to have 3 standard deviations. Okay. Standard deviation of 12, so add 12 for each section this way and subtract 12 that way. It does say to label the distribution curve, so you should put in the percentages. Remember, these are 34%, 13.5%, 2%, and 0.5%. So 68% of the students would have a score between here and here, because 34 plus 34 is 68. So that's between 67 and 91. A weird shadow on this, I'm sorry. If I stand over this way, it'll be better. So 95% of the data, remember, is from here to here. You leave off the 2.5 on either side. So that would be the 95%. So that's from 55 to 103. What percentage of the students scored less than 79? That's half of them, 50%. What percent is between the 55 and the 91? So from 55 to 91, you have 13.5, 34, and 34. That adds to 81.5%. If I've gone a little bit too fast, this would be a good time for you to pause the video and go back and just make some sense of your answers if you didn't match up with mine. Next, we're coming up with the z-scores. You take the value that's given, you minus out the average, and divide by the standard deviation. So you're going to do that on each of these. Okay, this one is going to give you a 1.5, a 0.2, and a negative 1.9. Next, same idea. Mrs. Green's test scores were normally distributed with a mean of 6, standard deviation of 1.5. So for the z-scores, you take the score minus the average divided by the standard deviation. Okay, calculate those, and you have a negative 1.3, a positive 2.7, and a 0.7. Okay. Question 4 is also looking for the z-scores. You have all these values here, though, that you first need to figure out the average and the standard deviation. The easiest thing to do is to put that in your calculator. You do end up with an average of 65 and a standard deviation of 8.4. Now you're ready to put it into the formula. Subtract the average, divide by the standard deviation. Subtract the average, divide by the standard deviation. Subtract the average, divide by the standard deviation. 1.07, 0, and negative 0.83. Now let's talk about this z-score of 0. That should make sense because look, the value is the average. Okay. Number 5, this time you have a table. They're giving you the average and the standard deviation and the test score, the z-score, and you're trying to find the test score. So I'm going to use J, S, A, and G for my variables. Jacob minus the average of 80 divided by the standard deviation of 6 is equal to a negative 0.5. So when you cross multiply, or just multiply by 6, however you want to think about it, on this one you're going to get a negative 3. When you add the 80 to both sides, you got Jacob to have a score of 77. I want to check your answers real quick. There's 77, 90, 95, and 64. You're going to do Sophie minus 87 divided by 2.5 equals 1.2. Avery minus 82 divided by 5 equals 2.6. And Garrett minus 84 divided by 8 equals negative 2.5. You should be able to solve those. If you have any trouble, just give me a call. We can work through them together. For number 6, you've got the scores from a golf tournament, and you've got the average, and you've got a standard deviation. And you want to figure out where your z-scores are greater than 0.5. Well, we have solved inequalities, so this is no problem. You want to know which score, that's our variable, minus the average of 70 divided by the standard deviation of 4.9 is greater than the z-score of 0.5. Multiply by 4.9. I haven't been showing this step, but hopefully you guys have figured out what I'm doing here. These cancel, and then 0.5 multiplied by 4.9 is 2.45. Add 7 to both sides, and you have to have x greater than 72.45. So it says circle all the values that have a z-score greater than 0.5. Well, that's the values that are bigger than 72.45, which would be these 4 answers: 73, 73, 76, and 78. Okay, the last one is very similar. These are the number of medals won by the top 10 countries in the 2014 Winter Olympics. You have a mean and you had a standard deviation. You want all the values that fall within one standard deviation of the mean. Well, the easiest thing to do that is just to think about what the mean is, 20.4, and what the standard deviation is, 7.9. They have to fall within positive and negative 7.9 from the mean. So the value minus 20.4 divided by 7.9, that's the standard deviation, has got to be greater than 1 or less than 1. Now, absolutely you can solve that, but we know the standard deviation and we know the mean. So all we really need to do is take that average of 20.4 and add the standard deviation and subtract the standard deviation. So 28.3 and 12.5. So the values that are within one standard deviation are going to be between the 12 and the 28.3. You can definitely write it as an inequality if you want to, but you're just looking at these values and circling them. So the ones that are between 12 and 28.3 would be these. This one's too big and these are too small. And that's it. I strongly recommend you go back and look at any that you've missed before you take the homework quiz.